A few more previous year IIT questions. Let's read question number 4. 3 points form a triangle. Something is given. Prove that the triangle is equilateral. So what is given? Let us focus on that. Division. You know how to handle division. So Z1 and to Z3, Z3 to Z1, we have drawn it out here. So Z1 comes first, the arrow pointing towards Z1 from Z3, and the arrow pointing towards Z2 from Z3. So this is what it is. And let's say this is the angle. So division basically gives us the angle, as you remember. Now what is this? This is half minus I into root 3 by 2 cos theta plus I sin theta. Just square them and see. 1 by 4, 3 by 4, they add up to 1. So the length of this complex number is 1, which means it is just EI theta. So that exactly is what they have given us. Now what it shows is that this length and this length are equal. If they were not equal, then R2 by R1 should have come here. It would not have been 1. Though it is 1, it shows that these sides are equal. And let's look at this once again. Half is cos theta, minus root 3 by 2 is sin theta. Just check, sin by cos is tan theta, so tan theta becomes root 3, minus root 3, which is 60 degree, minus 60 degree. So minus and plus depends only on the direction. So this theta is 60 and the sides are same, so it becomes an isosceles triangle with 60, so obviously it's an equilateral triangle. Let's move on to question number 2. Look at the question. A man walks 3 kilometers towards northeast, then walks 4 kilometers towards northwest to reach P. Give coordinates of P as a complex number. Let's take this as an origin. Northeast means this is east and this is north. So northeast is 45 degree. He walks here up to here 3. Then from here, what is northwest? Northwest is this direction because this is west. So from here he walks northwest for 4 kilometers. This obviously is 90 degree because as you can see this is 45 and then he walks at 45 again to the x-axis. So this is 90. And finally we join these 2 points and this distance is obviously 5 because 3, 4, 5. Now we want to know what is the coordinate of this point. How do we do that? Okay. Just look at this 3, 4, 5 triangle and this is 45 degree, right? If this triangle seems to be tilted. So if we had this triangle like this, 3, 4, 5, we would have said that this is 3, this is 4, so this point is 3 plus 4i as per complex number. So this point P coordinates would have been 3 plus 4i. But now the whole triangle has got tilted by 45 degree. So this 5, which was making some theta here, so P in this case could have been written as 5 EI theta, R theta. But now this 5 has got tilted by how much? 45 degree. The whole triangle has got tilted by 45 degree. So now the P will be 3 plus 4i into e to the power I pi by 4. Here, why we are writing 3 plus 4i? Because otherwise we would have to write 5EI theta, where the theta we have not found out. But theta, of course, we can find out. Tan theta is equal to 4 by 3. But instead of that, we are writing the z itself. The original z here is 3 plus 4i. 3 plus 4i, another way of writing 3 plus 4i is 5EI theta. But we are doing this because we don't want to get into theta. So this problem is also solved. Now let's see the third question. Z1 equal to a plus I, Z2 equal to 1 plus bi, Z3 equal to 0 form an equilateral triangle. Find AB if AB is our real numbers. Okay, so seems to be simple. So we have this coordinate, one of them is origin, one point is A1, so let's say one point is A1 and the other point is 1B, so the other point is 1B. They make equilateral triangle as it is stated. So all these three lengths are same, so we'll have to use that to find A and B. So seems to be a simple algebraic thing. Just work it out. This distance, all the distances are same. Let's say the distance is d squared becomes a squared plus 1 for this, becomes b squared plus 1 for that, which gives us b is equal to plus minus a, right? So this is one first equation that we have formed. Now look at the other side, that is a minus 1 whole square plus b minus 1 whole square. Since we are squaring, doesn't matter, 1 minus b, a minus 1, 1 minus b, b minus 1 same, is equal to a square plus 1 or b square plus 1. Let's take a square plus 1 and change b into plus a. So putting b equal to plus a, we get a minus 1 whole square into 2. So 2 into a minus 1 whole square equal to, this is a square plus 1. So a square plus 1, and this is a simple quadratic which you can work it out. I suppose we don't need to go ahead and do that. Let's take b equal to minus a, then what we get is a minus 1, and this becomes minus a minus 1, so this becomes plus a plus 1 whole square equal to a square plus 1. This also is a quadratic, but let's see what happens. We get a square minus 2a plus 1 and a square plus 2a plus 1. It is better to write vertically because adding becomes very simple, and so this is equal to 2a square plus 2, and this side is a square plus 1, so it becomes a square plus 1 equal to 0. A square plus 1 equals, so this is, a is not a real number. It's because a square is minus 1, but it was given in the question. If you see the question, it was given a, b are real numbers. So the second one will not apply. You will just have to calculate the quadratic equation by that minus b by 2a plus root d by 2a formula, and you'll get it.